All right, so they want us to find the intercepts, X-intercepts and Y-intercepts. All right, so since the point 0, 0 is on the graph, the Y-intercept, where this crosses the y-axis, is at the point 0, 0. All right, well, that also means that 0, 0 is one of my X-intercepts. So that one point is both an X-intercept and a Y-intercept. But now we want this other intercept over here. So if we know the midpoint is at 2.4, parabolas are symmetric. So if it takes 2.4 to go halfway, that means that the other intercept is going to be at 4.8. 2.4 times 2. 2.4 is the midpoint to 4.8. So those are our two X-intercepts, and they look like that on the graph as well, and our one Y-intercept. What do each of the intercepts mean? Okay, so the point 0, 0, that's the X-intercept and the Y-intercept, that is the height of the ball before it is hit, the moment before it is hit, or exactly when it is hit. That means time is 0 and height is 0. And then 4.80, that means at 4.8 seconds, the height of the ball equals 0. And what does the height of the ball equal 0 mean? That means that's when it hits the ground. On all of these motion type problems, when height is 0, that's when the ball hits the ground. That's when the diver hits the pool. That's when the baseball hits the grass. Okay, that's when height is 0. Describe when the ball is headed upward and when it starts coming back down. All right, well, looking at our graph, the ball is headed upward until 2.4 seconds. And then after 2.4 seconds, the ball is headed down. So upward from time between 0 and 2.4 seconds, and headed downward when time is between 2.4 seconds and 4.8 seconds. Okay, so here's a different function. Function dt, d of t, the function d that has t as its variable, describes the horizontal distance in meters traveled by the ball, t seconds. Okay, so this is not how high it's going, this is how far it is from the where it was teed off. So d, using the t variable, is 49.2 t. How far did it go? All right, well, we know that it hit the ground at 4.8 seconds. So what is the distance at 4.8 seconds? That's going to be 49.2 times 4.8. And 49.2 times 4.8 is basically 236.2 meters. Horizontal distance from the golfer. The distance for golf shots is traditionally measured in yards. Okay, so we want to convert meters into yards. So we have 236.2 meters. We want to multiply by something that has a fraction that has meters in the denominator. And we know that 1 meter is 3.28 feet. All right, that will convert it to feet, but we don't want feet. We want yards, so we have to multiply it by another fraction that has feet in the denominator and yards in the numerator. And we know there's 1 yard for 3 feet. So this is just like multiplying by 1, multiplying by 1. But meters cancel from numerator and denominator. Feet cancel from numerator and denominator, and now we multiply across. 236.2 times 3.28 divided by 3 is going to wind up being 258.2 yards from where it was teed off. All right, so for those of us that are Cub fans, we remember this night they're going to tell us about different application on November 2nd, 2016. We know where we were. Raji Davis of the Cleveland Indians hit a 2-run homer that tied the game, Game 7 of the World Series. They don't even mention the Cubs in this example. Anyway, using home run tractor data, I was able to find a function that models the flight of the ball. Okay, so here's our function, and it is a quadratic because it's something x squared, x to the first, and a constant. And x is the horizontal distance in feet from where the ball was hit. X is the horizontal distance in feet from where the ball was hit, and f of x is the height. All right, so we're going to go to the next page, and let's find out about this ball. I'm going to go ahead and rewrite the function here. So the height of the ball at x feet from the batter's box is negative 0.000175 x squared plus 0.6315 times x plus 1.9. That's just our function from the previous page. Okay, how high was the ball at the time it was hit? Okay, so how far away are you from the ball the moment it's hit? That's going to be 0. This is going to be f of 0. That's the height of the ball right when it's hit. So that's going to be negative 0.00175 squared plus 0.6315 times 0 plus 1.9. So the height of the ball, the moment it was hit, that's going to be zeros, is 1.9 feet off the ground, which is, probably as Raji was taking his swing, not quite 2 feet off the ground. That's the height the moment the ball was hit. Find the solutions. They could say find the zeros, find the x-intercepts, find when the function equals 0. That's what they mean by solutions to this equation. All right, well, we can't factor. We don't have two numbers. We can't factor this, so we're going to have to use quadratic formula. So, for this function to equal 0, 175 x squared plus 0.6315 x plus 1.9. If I want the values where this equals 0, the quadratic formula says the values for x where the function equals 0 is negative b plus or minus the square root of b squared minus 4 times a times c, the whole thing over 2a. This is called the quadratic formula, and it is kind of error prone, so you have to definitely take your time here. A is the number negative 0.00175. B is the number 0.6315. And C is the number 1.9. We're going to plug these three values into this equation, and then we're going to do this on our calculators. So I'm going to put this on a separate sheet of paper here. Negative b, both the plus and the minus of the square root of b squared minus 4 times a times c, the whole thing, over 2a. Now it's time for me to plug in my values for a, b, and c. This will equal 0 at negative 0.6315, that's negative b, both the plus and the minus of the square root of 0.6315 squared minus 4 times negative 0.00175, that's A, times 1.9, that's C. I know this is long and tedious, but we just have to take our time and do it. This whole thing is divided by 2 times A. So I haven't done any calculations yet. All I've done is plugged in these three values where they were needed for A, B, and C. All right, so X is going to be negative 0.6315, both plus and minus. Okay, and I'm going to try to do this on my calculator. Okay, you can see that there. 0.6315 squared minus 4 times negative 0.00175, close the paren, and multiply that by 1.9. This whole calculation is what goes right there. So that's 0.412092225. That whole thing over 2 times negative 0.00175 is negative 0.0035. All right, so what is the square root of 0.41209? That's my next calculation. I'm going to put square root and then go up and pick my decimal there. So this is X is going to be negative 0.6315 plus and minus 0.641944. That's probably long enough. Over negative 0.0035. So now X can have two values. Negative 0.6315 plus 0.641944 over negative 0.0035. That's the plus. And on the other side, X can have, when we do minus, negative 6.315 minus 0.641944 over negative 0.0035. All right, and now I'm going to do this on my calculator. So alpha, my alpha key, my green key, Y, you can pick numerator and denominator and it will give you a fraction. So in my numerator, I'm going to put negative 0.6315 plus 0.641944. And in my denominator, I'm going to put negative 0.0035. So the distance where this is equal to 0 is at negative 2.984. All right, so we're going to disregard that. And then the other one is when we subtract. So I'm just going to go change that plus to a minus. And that's at 363.84 feet. Well, this doesn't make sense to have a negative feet. But that was a 363.84, almost a 364-foot home run that Rajay hit. Let me go ahead and put that answer here. Find the solutions to the equations and describe what each mean. X equals negative 2.984. That's nonsense in this case. And X is also 363.8 feet. And that means that it was a 363.8-foot home run from home plate. It hit the ground, I don't know, in the bullpen or wherever, 363.8 feet away. Okay, so the home run fence is 19 feet high at the point where the ball went over it, which is about 325 feet from where the ball was hit. By how much did the ball clear the fence? Okay, so let's take a picture of this. Here he is at home plate. Here's the 19-foot fence, and this is 325 feet away. Here's 363.8. This is where the ball hit the ground. So we want to know by how much did the ball clear the fence? Well, we have to know how high the ball was at exactly 325 feet. So how high was the ball at 325 feet? That's going to be at negative 0.00175, 325 squared, plus 0.6315 at 325, plus 1.9. We are definitely doing this on our calculators. So negative 0.00175 times 325 squared plus 0.6315 times 325 plus 1.9. Okay, so this fence is 19 feet high, and the ball at that point was at 22.3 feet. So 22.3 minus 19. Basically, it cleared the wall, it cleared the fence by 3.3 feet. But the Cubs won.